Gentlemen, this is Mr. Green, and this is another in my series of Algebra 2 lessons. Let's see, is this working correctly? Yes, okay. We're going to be looking at uh, Unit 2.9. So you should be working on Unit 2.9 right now. Remember, after 28 days of a particular assignment being open, it will lock up. So I do not want you getting anything locked up on you. I want you to make certain you're getting things taken care of before they get locked, okay? So make certain you get things taken care of. The best way to stay out of trouble with the grade book is make certain you're staying current with your work, okay? Okay, having said that, we're going to be solving some logarithmic equations. You're going to use logarithmic and exponential properties to solve logarithmic equations, okay? So let's look at just a few of them here, okay? First of all, this one says solve and check, and you're going to be, if you can write an equation in the form log sum b sum base a is equal to c, then you can use the definition of logarithms to write the equivalent exponential equation. This strategy can be helpful for solving some problems. What I'm trying to point out to you here is, here we've got log 64 is equal to x. Well, you know what? This is actually 4 to the x power is equal to 64. That's the exponential form of this same thing. Remember, base goes here, power goes there, and then this is the number that goes there. And what you're trying to find is x, right? Well, if you know your 4s, 4 times 4 is 16. 16 times 4 is 64. So this has actually got to be 4 to the third power. So you know x is equal to 3. That's how these things can work for you and can help you. Same sort of thing over here. You've got this problem. Well, you know what? This actually looks difficult to me to solve using the log properties. But if I took 7 squared is equal to x plus 1, that's not that different. That's 49 is equal to x plus 1. Okay? That means that x is equal to 48. That was much easier to solve than this log problem. So sometimes it's a matter of looking at the problem and converting it back to the exponentials and solving them that way. Let's look at this one here. I see this problem here, and I know what I'm going to be doing. I can see that by having a plus sign in here, I'm multiplying together. So I've got log 2 is x plus 2 times x minus 5 is equal to 3. Right? And then what I can do is say that 2 to the third power is equal to x plus 2, x minus 5. Well, 2 to the third power is 8. And I can expand this using FOIL, and you get x squared minus 3x minus 10. And so if I subtract the 8 from both sides, 0 is equal to x squared minus 3x minus 18. Now I can factor this. All right? What multiplies to give me 18? 2 and 9. Well, that's not going to do it. How about 3 and 6? That would do it. I could say 6, x minus 6, and x plus 3. Why? Because minus 6 and 3 gives me a negative 3, and 6 times 3 gives me a negative 18. So that means that x is equal to negative 3, or x is equal to 6. That's all we're looking at. You can see how converting it back to an exponential form here helped me. I used one log property here to make certain that I multiplied these together so that when I did convert it back to an exponential form, it gave me something I could factor. And once factored, I got values for x. Okay? Okay, so let's go on here. So this one says solve and check. So when I see this, one of the things I'm thinking about is that I'm going to have log to the base of 5 of x plus 6 divided by x and 4x. How did I get 4x there? Well, I subtracted this from the other side, and that's equal to 0. So that's 5 to the 0th power is equal to x plus 6 divided by 4x. Well, 5 to the 0th power is 1. And I can multiply by 4x. I'll get 4x is equal to x plus 6. 3x is equal to 6. X equals 2. Do you see how I worked through that so fast? The trick here was making certain that I subtracted this from both sides. Okay? And then I see subtraction and subtraction. That means they're being divided by here. And that's where I got that information. Converted it back to an exponential form. Recognized the 5 to the 0th is 1 multiplied by 4x. Solve the equation. Got x equals 2. Okay? We're using these log properties to get things done. Okay, here we've got two things that are to the base 10. I see something being multiplied here, so what I'm going to think is log 10 r squared equals log 10 square root of 64, or 8. You know what? I can see that is log 10 of r squared divided by 8 equals 0. Why? Because I subtracted it from both sides and then combined it together as the division problem. Now if I convert this back to exponential form, I'm going to have 10 to the 0th power is equal to r squared over 8. That's 8 is equal to r squared. R is equal to the square root of 8, which is 2 square roots of 2. That would be my value for r that I would have picked on this one. Okay? Couple more problems here. Log 381 equals x. Convert that back to exponential form. That's going to be 3 to the x power equals 81. Well, I know 81 is divisible by 3, and as a matter of fact, I think it's 3 to the 4th power equals 81. That means x has to be equal to 4. For this one, 6 to the 8th power equals 6. Well, you know what? It's got to be a 1, doesn't it? Because if I divide by 6, that's going to give me a 1 there. So it's got to be a has to equal 1, because it's the only value for a that would make this be true. So the question becomes, how do we know whether to solve it as an exponential or as a log, or which way to go? You know, the easy way to say this is, if I'm looking at it and it looks like it's going to be a hard log problem, I convert it to exponentials and see if that's going to be any easier. If it's in exponentials and it looks like it's going to be hard, I convert it to a log problem and see if that's going to make it any easier. It truly is a factor of just trying it a few times and getting used to what you're looking at to be able to know which way to go. Typically, if you're given a log problem like this, if I don't see an immediate solution to it, I go ahead and convert it back to exponentials, because that's what we're going to be doing in this type of a class. Okay? So what's 2 to the 5th? Well, that's 2, 4, 8, 16, 32. Subtract the 4 from both sides, and you're going to have what? 28 is equal to x. You can see these don't work out to be difficult problems. It's just a matter of writing them down in the other form. And that you can see I'm taking the base, I'm taking the what it's equal to, 6 to the 4th, and that's the value that would go here. That's the opposite of doing the log, so I'm just doing the exponential form here. So 6 to the 4th, that's 36 squared. I cannot do my 36s. I just am not that good. So 6 raised to the fourth power is going to be 1,296. 296 equals 2x plus 8. Well, I'm going to subtract 8 from both sides. I'm going to get 1,288 is equal to 2x. And if I divide by 2, I'm going to get that x is equal to 644. Wow, that didn't seem like that was that difficult. That's why converting back to exponential sometimes is great. Okay, this one is giving you a clue. See where it says right here, check for extraneous solutions? That means not everything that I'm going to get out of this one is going to be a valid number. And I'm going to have to go back and check for it. Okay? So what I want to do here is I'm going to say 81, I'm going to take the 1/2 power, that's the square root, is equal to r minus 5, r plus 3. Because those are going to be multiplied together. It's going to give me 9 is equal to r squared minus 2r minus 15. Subtract the 9 from both sides, and I'm going to get that 0 is equal to r squared minus 2r minus 24. Let's see here. 6 times 4 is 24, right? 12, 24, yes. So that's going to be r and r. So we're going to have a 6 and a 4, and the 6 has to be the negative 1, the 4 has to be the positive 1. So we're going to get r is equal to 6, and r is equal to negative 4. So let's go back and plug those into these equations up here, the first equation, because we've got to look for extraneous solutions, ones that don't work. So if I say 6 minus 5, that's 1, so I've got log 81 of 1 plus log 81 of 9, and they're asking equals 1/2. Well, I'm going to multiply these together because they're being added. 9 times 1 is 9. So I've got log 81 of 9 equals 1/2. Well, that's, if I convert this using logarithms, that's log 9 divided by log 81, and they're asking, is that 1/2? That's really what it's boiling down to. So I'm going to press log 9 divided by log 81, and I get 1/2. So that one checks. So that one will be a good answer. Okay? So I want to go and check the other one. So that's going to be log 81, and negative 4 minus 5 is a negative 9. And then log plus log 10 of, let's see here, negative 4, that's negative 1, equals 1/2. So I'm going to once again combine these together, and I'm going to have log 81 of 9, negative 9 divided by negative 1 is a 9, equals 1/2, and that's exactly the same thing as what I have there. So guess what? Even though it says check for extraneous solutions, both those solutions work. And I don't see an extraneous solution in that one. But that's what you have to do, is go back to check them and make certain that they work. Okay? Okay. Let's do the same thing on this one. So we've got um, log 6 of 2y plus 3 divided by 7y equals 1. No, 0. Why? Because I subtracted the log 7y here, and since I had a subtraction, I went ahead and divided them. So this is going to be log, or 6 to the 0th power is going to be equal to 2y plus 3 divided by 7, y. So I'm going to multiply the 7y on the other side because that's going to be 1, right? So I'm going to get 7y is equal to 2y plus 3. Subtract the 2y, I've got 5y equals 3. Y is equal to 3 over 5. Wow, easy enough to solve for. Okay, let's go forward. Let's save some of these for Class Connect sometime and we'll work them there. I want to make certain you guys remember, send me, when you're sending me information, make certain you're including the fact that you're in Algebra 2. It really does help me find your information a little bit quicker and respond to you a little bit quicker. And I don't want to confuse your work with other people's work, so it helps. It really does help. And I don't forget I've got tutoring on Tuesday, Wednesday, and Thursday, and I look forward to seeing you next time.